Examples. The first example is as follows. Given the joint probability given the joint probability density function, then probability density function, which function is that? So remember that in the other framework it was f of x was f of x, f of one variable. Now this is multivariate, so this is 3/5 x y minus x, and we have both ranges, that is the range of x values and also that of y values. Then it is 0 elsewhere. Given the joint probability density function of two RVs x and y, comma, part A, show that the double integral over all x, all y, f of xy dx is a 1. That is part A. Then part B, find the probability of xy, xy is in A, where A is the region, xy, such that you have 0 less than x less than half, and 1 is less than y less than 2. That. So part A, we start with part A. Show that the total probability is 1. That should be very easy to deal with. Solution. Part A, we are evaluating over all x, all y, f of x. F of x. Now, f of x, I think this was supposed to be, kindly correct this. This was supposed to be the x, the y equals 1. Of course, what you start with depends on the limit which you want to start or end with. So this is equal to, so this, the x, the y, this should be the integral of, substitute your function. Look at the question which you've noted down. The function is 3/5 x y minus x, and the dx comes first followed by dy. You can as well start with dy. If I start with x, what were the limits of x? If I start with x, you see x is from 0 up to 1, that is x. Then y is from 0 up to 2. X is from 0 up to 1, y is from 0 up to 2. Therefore, this is equal to the integral from 0 up to 2. Then I integrate. I hope we are together, maybe before. Okay, before I integrate, let me first open brackets. Before I integrate, we have 3 over 5 x, y. I'm opening brackets, minus 3 over 5 x squared. X squared dx dy. That's what I have. This is equal to the integration from 0 up to 2. Now I integrate with respect, because x comes first. X comes first. So you start with integrating with respect to x. With respect to x, this will be 3 over 5 x squared over 2 times y. Now y is looked at as a constant, then minus 3 over 5 x power 3 over 3. What are the limits? From 0 up to 1. But the y is still there. Therefore, this is equal to, from 0 up to 2, substitute 1 where we have x, because from 0 up to 1, those are limits of x. So what shall we have? If I substitute a 1, we shall have, particularly where I have x, 3 over 5 times 1 squared minus 2, y is there, then minus 3 over 5 times 1 power 3 over 3 minus, when I substitute a 0, particularly where I have x, 3 over 5 times 0 squared over 2 times y minus 3 over 5 times 0 power 3 over 3 over 3. So this is what I have, y. Therefore, this is equal to the integration from 0 up to 2. Simplify now. Simplify what is in the brackets. I am left with, hope you agree with me, that I have 3 over 10 y, 3 over 10 y, then minus 3 over 10 y minus 1 over 5 y. Then this is equal to, now I integrate with respect to y. 3 over 10 times y squared over 2 minus 1 over 5 times y from 0 up to 2. Then substituting, this is equal to 3 over 10 times 2 squared over 2 minus 2 over 5. Then take away 3 over 10 times 0 squared over 2 minus 1 over 5 times 0. So simplifying this, I hope you agree with me that if I simplify this, this will be what? This is equal to, up there I have what? So therefore, this is 3 by 2. This is a 1 by 2. We remain with a 2. That is by 2, 1 by 2, 5. So this is 3 over 5 minus 2 over 5. And this is 1 over 5, which is not 1. Because what did you want to show? We wanted to show that the total probability is 1. Now I've been able to integrate and I am getting 1 over 5, which is not 1. So this should imply that the integral over all x all y f of x y dx dy is not equal to 1. Therefore, for that case, fxy is not a probability density function. Because if it is a probability density function, then the answer would have been 1. And for that case, we cannot solve part B. Maybe if part B was the first, then we would have been in position of obtaining that. But it's not a PDF. It's not a PDF. Yeah, it's not a PDF. So part B cannot be worked out because part B deals with the probability, and here the condition probability is not being satisfied. Hope I'm clear on that. Maybe I note it down here so that you are not confused. For part B, required probability cannot be obtained since f x y is not a valid probability density function. Not a valid probability density function. However, if that density function was modified to have example 2, what does example 2 say? That what does it say? It says that given that f x y, which is 3 over 5 x y plus x, Now, initially, I was dealing with the y minus x. Now, this is y plus x. Given that this function is 0, otherwise, given that that function is a joint, and that function is a joint probability density function, of two random variables x and y. The joint probability density function of two random variables x and y. Use it to find a probability of xy in A, where A is the region defined by the region defined by x, y, or such that 0 less than x less than a half, 1 less than y less than 2. That's what we have. Now here, given that it is a joint probability density function, a find is already, we don't need to first verify because the question has been so categorical. Don't verify, just find what is right. But for the other first example, I did not progress because I realized that there was something wrong with that density function. So here, I assume that my density function is properly defined. Therefore, on that note, allow me So the required probability, that case, probability case, solution. I hope you've taken note of the question. The required probability of x, y to be in A. So the region A has been defined. This is the same as probability of 0 less than x less than a half, 1 less than y less than 2. So you see, you can decide to start with x or y, it doesn't matter. So if I start with x, x is starting from 0 up to a half. Then y starts from 1 up to 2, according to how the region is defined. Yeah. Then the probability density function is 3 over 5 x, y plus x, y plus x. Now you see the first limits from 1 to 2, that is y. So dy first, followed by dx. Dy first, followed by dx. 3 over 5 x, y plus. So still we evaluate this double integral from calculus 3. You've looked at these things. So this is from 0 up to a half. I can, for simplicity, I can first decide to open brackets. So we shall have 3 over 5 x y, if I open brackets, y, then plus 3 over 5 x squared dy. And this is the integral from 0 up to a half. So I first integrate. There's something I'm missing here. Sorry. This is dy dx from 0 up to a half. So we first integrate y. Y is the one which is varying because I start with limits of y. So this will be 3 over 5 x times y squared over 2, then plus 3 over 5 x squared y. We are substituting limits from from 1 up to 2 dx. That. Therefore, this is equal to, I feed in those limits. From 0 up to a half, I feed in those limits. Feeding in to where we have y, because those are limits for y, we shall have 3 over 5x times 2 squared over 2 squared over 2 plus 3 over 5 x squared times 2, then minus, if I feed in a 1, 3 over 5 x times 1 squared over 2, then plus 3 over 5 x squared, 3 over 5x squared times a 1. That is, if I substitute in a 1 dx, like that. Simplifying this, this is the integral from 0 to a half. So simplify. If I simplify inside there is hope you can agree with me that there is this 2 reduces with that, so I'm left with a 6 over 5x, then plus 6x squared over 5, then minus 3 over 10x, minus 3 over 10x, then minus 3 over 5x squared dx, like that. Then you subtracting there. This is the integral from 0 to a half. Subtracting, collecting right terms. I hope you agree with me that this now 3 over 5, 6 over 5, sorry, and the 3 over 10, they can be put together. So if they are put together, that is 6 over 5 minus 3 over 10. What do you get? That is 12 minus 3. 12 minus 3. That is 9 over 12 minus 3. That is 9 over 10x. Then plus also those ones that have x squared plus 3x squared over 5 dx. Then integrating this is equal to 9 over 10 x squared over 2 plus 3 over 5 x power 3 over 3, 0, half. So this is the same as 9 over 20 x squared plus 1 over 5 x cubed, 0, a half. So if you put in a half and a 0, this will be 9 over 20 times a half squared plus 1 over 5 times a half power 3. This is equal to 9 over, that is a 4, 9 over 80, 9 over 80, then plus 1 over 40. It's 1 over 40. So when you add those two, what do you get? You have 9 plus 2. I want to believe that this is 11 over 8. Yeah, 11 over 8. Simple as that.